so again, we can set up this problem because we know that, again, we're solving for volume. We know the volume of a rectangular prism is length times width times height, because really the area of a square, or sorry, a rectangle is length times width, and then when you stack them on top of each other, you have h times number of length times widths, right? So then all we do is we fill in the three different sides that they give us, which is x, x minus 1, x minus 2. We multiply them together, and we know that that equals 24. So what you would do is you would go ahead and multiply. So you're going to distribute. What I would do is I would distribute x minus 1 times x minus 2 first, and then multiply the x afterwards. So x times x is x squared. We have minus 2x. And then we have minus x plus 2 equals 24. 24 equals x times x squared minus 3x plus 2. If you skip some steps, that's totally fine. I'm just trying to show you what's happening here. All right. So we're almost set up. You can see here that really what I'm doing is I'm just multiplying everything together and then combining like terms. The last thing I'm going to do is subtract 24 from both sides, and I get 0 equals x to the third minus 3x squared plus 2x minus 24. So if this looks familiar to you, that's great, because we want to solve for the roots, right? To solve for the solution, we want to solve for the roots and see what is possible here. Okay, so to solve for the roots, what I would do is I would put it in my calculator. So let me go ahead and put it in the polyroot finder. Okay, so we can see that on our polyroot finder, we're really given one real root to try. So we're going to first use synthetic to solve for it. So the only root we're given is 4. So we're going to go ahead and use synthetic to test whether there are other roots. So now I'm at x squared plus x plus 6. Let me just slow down actually a little bit. So what I did is I used my polyroot finder on my calculator. I found that there's 3 roots. 2 of them look like they might be roots, but I'm not sure. So what I'm going to do is I'm going to use synthetic to test whether 4 is indeed a root, and it is. And the second thing I'm going to do is I'm going to use quadratic formula to make sure that the other 2 roots, I can rule them out, right? So the reason I can use quadratic is this equation stands for x squared plus x plus 6. And so I'm going to use quadratic formula to test. So x equals -1 plus or minus the square root 1 squared minus 4, 1, 6, all over 2, 1. So I want you to stop and consider here whether this could be a possible solution. Even though I haven't done any math yet, I'm just filled in my quadratic formula. You can see here that these other 2 solutions are not going to be useful to us. Can someone tell me why are these other 2 solutions not useful to us? So without even solving the quadratic formula, I can already look at this and I know that this is not going to be 2 additional solutions. Why is that? Why is that? So looking at our quadratic formula, is there anything you guys can see? Oh, it is kind of small. I'm gonna zoom in here. So looking at our quadratic formula, what would tell us that this is possibly, these two are not solutions? Emily? The number in the square root is going to be negative. Okay, so you can see here that 4 times 6 times, well, negative 4 times 6 is going to equal negative 24, which you're going to subtract from 1. So you're going to get a negative number under the square root. That means you're going to get some imaginary number, some weird imaginary number, but you can't have imaginary number length for the side of a rectangle. So because you can't have an imaginary length for the side of a rectangle, you could just go ahead and you could just cross this out and say, well, that's not possible, right? That's not possible. So the only real answer here is 4, right? So that means x is equal to 4. So let's solve for each of the sides of the rectangle. So we know that one of the sides of the rectangle is equal to x. We know one is equal to x minus 1, and we know one is equal to x minus 2. Okay, so we know, again, we know that one of the sides of the rectangle is equal to x, one's equal to x minus 1, and one is equal to x minus 2. So if I just fill in x for 4, I know one of the sides of the rectangle is 4. One of them is 4 minus 1, which is equal to 3. One is equal to 4 minus 2, which is 2. And I have all the sides of my rectangle, so I know that one side is equal to 4, one is equal to 3, and one's equal to 2. Okay, does anyone have any questions on this one? So you would answer this by saying the sides of the rectangle are 4, 3, and 2. Let's see if I can. So you would say the sides of the rectangle are 4, 3, and 2. And again, the reason why we eliminate 2 of the answers is because when we use quadratic formula, we get imaginary numbers, right? We get imaginary numbers. So those are not going to work as sides of the rectangle.